This video will demonstrate our Relay Settings Automation Program, or RSA as we call it. The purpose of RSA is to automate the workflow required to correctly determine relay settings for an SEL 421 or 311C relay. The end result of an RSA run would provide the updated RDB file to be loaded into the relay. RSA was written in the Aspen scripting language. In order to run RSA, Aspen One-Liner, which is a commercially available short-circuit program, a calc sheet, which is a utility-specific engineering document, and an RDB file are required. So let's look at a file that contains those three. We have a calc sheet, our RDB file, and our one-liner case, or our OLR file. First, let's look at the RDB file for an existing 421 relay. This will actually be updated after running RSA. This is QuickSet Accelerator that we're actually opening this in. We just want to look at a particular CT ratio. We see a value of 600 to 1 for our CT ratio for this case. Note that when we open the calc sheet, its values will show a ratio to 5. So 600 to 1 should equate to 3000 to 5 in our calc sheet. So let's close this RDB file now that you see the value. And let's open our calc sheet. This calc sheet actually has 12 worksheets that it uses, but we are mainly focusing on the one called Aspen to Calc. This is the one that we added, and all the information that we get from Aspen will be placed in the sheet for the utility to use. This information can include impedance values, the lengths of second lines, transformer information, and results or summary results from all the different faults that are required. Notice that this calc sheet already has some information in what we call the data entry section, and is highlighted in yellow. Here's our CT ratio of 3000 that we were just discussing for our RDB file. Now, once you get past the data entry section, highlighted with yellow again, everything else in this calc sheet is blank. You can see it's over 8,000 lines. The appropriate information will be filled in when RSA has actually run. So now, let's look at a simple case. This is a case that we made just for this demo. We want to calculate the relay setting for a 421 relay at this location. It is actually going to be protecting the main line, which you will see here, that runs from the main bus through a series of tap buses all the way to a remote bus or REM bus. Again, there's several taps along the way, several transformers. You have several second lines at the remote bus. You have several transformers at the remote bus. So we're going to use this case and actually run RSA. You run the program by selecting the relay location, then actually running our script. Our script is called RSA Functional. So we're going to select that, and it will bring up a series of dialog boxes. The first dialog box you see is sort of the setup file. You will see the name of our OLR file already grayed in because it's using the one we have open. And next you will need to select your 421 calc sheet. So we will browse to our location and select the calc sheet. Next, it will prompt us to select the RDB file. Now, if we wanted to include the 311C, we could check this. You would also have to provide a calc sheet and RDB file for that. But we're not going to do that at this time. Once the file information has been input, you can actually select the outage list type that you want for the fault calculations. You can either select an Aspen outage list, where you can specify the number of tiers that you would like to go back, or you can select the walk back method, which continues walking back to the first real bus that contains at least 2 sources, or you can select both and it will compare the results to give you the best one. For this particular run today, we will select the walk back in the interest of time. I have run both the Aspen 3 tier and the walk back for this particular case, and I would like to point out that the walk back method ran a total of 121 faults in under 2 minutes, while the Aspen 3 tier method ran 6,132 faults in a little over 15 minutes. The next section deals with coordination, and we have that grayed out right now because they're not available at this time. We do want to check the export settings to RDB file because we do want to update the RDB file. So we have to check this box to do so. Once you click OK, it brings up another dialog box that indicates the breaker arrangement. This case is just a single breaker case. However, you could have double, ring, or breaker and a half. If you select something more elaborate than single breaker, you will also have to select the line or transformer that's in common to that breaker. Let's get back on single breaker, and then we'll have another dialog box. This corresponds to our data entry section that we saw on the calc sheet. Here's our CT ratio that we're actually going to change. It does read the values that are already in that calc sheet for this section, but you can overwrite them right here. So we're going to change that CT ratio from 3,000 to 5 to 1,500 to 5. And we're going to leave everything else the same. The next 2 dialog boxes are default values for margins. You can see the defaults that are grayed in. If you would like to change those values, you can type a number here and it will change it in the calc sheet. So we'll just change the highest seasonal 15-minute rating from 115 to 120, just to show you that it does change in the calc sheet. This is just the second dialog box for the default. We're not going to change anything there. And now the program actually starts running. You can see the progress bar, and it tells you what faults or what the program is actually doing, just so you can see the progress. If you had to sit there and run 121 faults, that could be tedious, and you could make a mistake or a typo when you're typing the numbers back into your calc sheet. Obviously, a human is probably not going to run 121 faults, because you could look at the diagram and determine what you needed to run. But this case, covers what is needed by the computer. So now it has actually finished running, and for the save process, we do close and reopen the Aspen model. Then we get this warning, to check a text file for some settings for the RDB file that need to be manually updated. And then RSA is actually finished. Now, if you notice, we have a new name on this OLR. It is appended with a -RSA, so that you know that we did modify your model. We have updated the relay settings, actually, in in this relay group. And if you look in the folder now, you'll see several more files in there. The first one we talked about just a second ago is, we have a new OLR. It just includes the information that we have changed. We have a new calc sheet that has been appended by the name of the outage list type that we chose. So you'll see the underscore walkback. You'll see a text file that contains the results of every fault that was run. The results of every fault will not be placed into the calc sheet. The best or worst case one, whatever the program or calc sheet is requiring. Does it need the minimum fault current? And if so, we'll run all the faults and find the minimum and only put that one in the calc sheet. But you do have the record of every fault that you ran for the system. This is that text file that tells you some things might need to be manually updated. You have a system info file that just summarizes what you actually ran, what outage list type, how many tiers back, that type of information. And you have a log file that basically gives you the version of RSA that was run, the version of Aspen, and just some other debugging information that we might need. So let's look at the updated RDB file. You can tell it was the time and date had, just the time had changed on this one. We're going to go back and look at that CT ratio. And again, the reason we're looking at the CT ratio is that's just something easy to see that has changed. And now you'll notice a value, instead of 600, which we originally saw, we have a value of 300 to 1, which corresponds to us changing it in the GUI from 1500 to 5. So it did update the RDB file. We'll close that. And now we'll look at the calc sheet. Again, the first thing we're going to look at is that CT ratio. It has been updated to show the 1500 to 5. And now if we scroll on past the yellow highlighted section, we do see information. We see that there are 6 second lines. You still are going to see a lot of blanks because we leave space for, I think it's 20 second lines, 20 transformers. It's only going to fill in the information that was actually needed. You'll see some distribution transformers down here. If we specify where to go, we'll see some of our fault analysis section. You'll see, again, it ran a lot of faults, but it puts, this particular, the best number in the actual calc sheet. Let's see. We have a breaker failure section that we're still doing some verification on, but appears to be working well. And if we scroll on down, here's some more fault information that is filled out at the very end. So, another thing we can look at, we did change that default. So we'll actually go over to the default sheet for that one. And we had changed that value from 115 to 120. So that will be the value that's used for that particular margin. Now all of these values that we changed in the Aspen to calc sheet are named ranges. So, if you set this up properly, this value will appear where it needs to in one of the 12 worksheets to determine the appropriate relay setting. Okay, so we're going to close the calc sheet and we'll look real quick at the RSA results file. Again, this is a summary showing all 121 faults that we ran. It tells what type of fault, the location, This is a great piece of documentation for what was actually done. If you wanted to look at a particular summary, like for instance, the row 1075 that goes into the calc sheet, we can do a quick search for that. And you'll see the summary of the longest second line row. It tells you what the longest second line was, the location, what the strongest source removed was, and your value. If you scroll up from there, you'll see, okay, this is where we begin our row 1075 calculations. So at the end of it, it'll give you a summary of what was selected and put into the calc sheet. So this concludes our demonstration today. The benefits of RSA, we hope that you could see, can include the elimination of human error from number copying, the standardization of the process, a reduction in time to set the relays, and a documentation for the process. Thank you for your time.